just spread-eagling the field in the Nissan GTR, and there he goes.
In this era of technical one-upmanship between nations, it seems Nissan has out-perfected Ford's near-perfect Group A car. Japan's response to the Sierra, the Commodore and the BMW M3 is this gem: a four-wheel drive, four-wheel steer, twin-turbo, six-cylinder, 24-valve rocket. Technology is the message, and Nissan has used the Group A rules to the max to create the ultimate touring car.
Well, the Sierra's got 550 horsepower, say, putting us through a 10-inch tyre on the rear. We've got 630 horsepower, a lot heavier, but we're putting us through four wheels.
You heard right, he said 630 brake horsepower. Using the most sophisticated milking methods, Nissan Motorsport is dragging massive horsepower from this six-cylinder turbo. But normally, having this much grunt smouldering away under the bonnet would be of little use, as it would be wasted in wheel spin, ultimately killing the tyres on most Group A cars. That's why four-wheel drive technology was embraced. Distributing that much power through four rather than two wheels allows the use of radical horsepower. However, merely driving all four wheels at the same speed is undesirable. Controlling the prescribed amount of four-wheel drive is the critical factor. This onboard computer receives constant messages from three sources regarding the behaviour of the car. A G-force sensor measures longitudinal and lateral forces, therefore monitoring braking, acceleration and cornering loads. A tooth drive on the rear diff output shaft monitors rear wheel spin. And each wheel has a speed sensor, and the information is logged by the brain. The brain deciphers the data and, according to the situation, commands a solenoid control in a device called an ETS pump. For example, if the rear wheels break traction, the ETS pump varies the amount of oil pressure to the transfer case, or put simply, gives the car more front-wheel drive. The transfer case clutch pack works on a similar principle to an automatic gearbox in your standard road car.
So basically how the system works is that when the rear wheels lose traction, directs drive to the front, we then have a four-wheel drive car, and we can program that by our silicon chip. So the car has a situation where on fast corners where there are high Gs, the car works as basically a two-wheel drive car. When it's on a slow corner with low Gs, the car is very much a four-wheel drive car. So out of slow corners it's great, around fast corners it's almost the same as a Commodore or a Sierra.
To complicate the issue, the brain can be programmed with silicon chips called EPROMs to react in different ways. Using data logging equipment, all this information can be recorded and used to achieve a better setup prior to the race. When the setup is right, the equipment is removed. This is just some of the information used. A test at Perth's Wanneroo Raceway reveals the variations in four-wheel drive pressure from the ETS pump. The forces on the car are plotted using half-G increments, and the actual speed of the individual wheels is recorded. Using the timescale along the bottom of the graph, this information can be cross-referenced and the car's track position can be pinpointed. Then if the Gibson team adjusts the car's suspension or alters the four-wheel drive settings, the information can be re-examined to decide if it worked or not. Once they've programmed the GTR to behave, the drivers have three other four-wheel drive control options. These are mode switches. If it rains, Richards or Skaife hits the appropriate switch and instantly they've got perfect four-wheel drive, overriding the brain's normal pressure variations. This is not your average touring car.
People ask me, how do you get used to driving it, being four-wheel drive against two-wheel drive? Well, really, the getting used to it takes care of itself in a way. The object of the exercise is to get around the track as fast as you can, and you make small adjustments at each corner depending on how the car drives out of it. But my first impression when I drove it really properly, I suppose you'd say, at Oran Park, was the fact that between slow corners, between two corners, it is exceptionally fast. Incredibly so that you've hardly got time to look at the rev counter. You've just put your foot on the accelerator and accelerate so fast you just change gear and go to the next gear. It's incredibly fast. That's the first impression that I had of it.
There is one flaw. The car is heavy and that has an effect on brakes and tyres. This weekend is the big test. Will the technology be a help or a handicap when it comes to attempting a win in Australia's toughest race?